what we're looking at now is estimating duration. So estimating is a guess, estimate. It's a guess and an estimate. And you can get it wrong, as this guy found out. So estimate work package duration. Once we've figured out what resourcing we need, we're estimating the duration if we had those resources. Now, it may be when you've gone through one iteration of the time management process, you find that you don't have those resources and you're going to have to go back and redo it. Okay, so it is part of an iterative process. So it's calculating the number of work periods, best periods to complete activities, work packages with the resources available. The work periods are the time measures, how you're going to measure time. In civil engineering projects, we usually use days, sometimes weeks, but not hours. Hours might be something like a computer software type of project, all those sort of things where they've got the same resources doing much the same thing. But with us, we usually use days. If you've got half a day, then round it up to a day. A duration is the number of work periods, the number of days from start to finish. And the effort is the work hours to complete the work. So it might be that you figure that the work effort is 24 staff hours to dig a 100-meter trench. So that means that one person is going to take 24 hours to dig the trench. If you had two people digging the trench, then it's going to take 24 divided by 2 people, which is 12 hours. If you had 4 people, 24 divided by 4, which is 6 hours to dig the trench. So you can see that the duration, the amount of time it actually takes, is dependent on the effort, number of hours it takes to do the work, divided by the number of resources. So as you increase the number of resources, you reduce the duration. Okay, and also duration, remember that you're only working 8 hours a day. So when we're talking about days, we're talking about work days. Not 24 hours, we're talking about 8 hours or 10 hours or whatever it is. So it's important that you understand those concepts. Duration, effort, and duration is equal to the effort divided by the number of resources. Now duration may also include weekends, and may also include lag and lead times as well. So estimate durations, how long each work package is going to take to complete. So you've got the work package requirements, and that's from the quantity and the quality. It's from the specifications and the drawings. So they'll tell you how many meters of pipe you need to lay, what type of pipe it's supposed to be, or in this case it's curb and channel, how many meters of curb and channel you need to lay, what's the concrete specification for it. It could be that the finish is quite a high standard, in which case it's going to take you a little bit longer, so that's where the quality sort of comes into it. And there's also the risk. If there's rain in the time that you allowed for the curb and channel work, they're going to stop. So there's going to be extra time required to do it. And so you should look at each one of these each one of these work packages and say, what's the risk of this thing running over time? I know that on a good day they're going to be able to do 100 meters of curb and channel in one day. But if it rains, then it's going to take a few extra hours. So if I've got a 500-meter section, I could allow 5 days, but if there's a chance of rain, I might allow 6 days. So risk comes down to the riskiness of it. Now, if you're talking about people putting something together in a warehouse, say putting together preformed frames, if it rains, it's not going to affect them because they're inside. So you need to look at each one of the work packages and determine how vulnerable it is to running over time. What events could happen that could cause this thing to run over time. And it's not just weather, it could be deliveries of materials, or the materials may not be in good supply, or it might be that the workers aren't as good as what you thought. So you need to look at each one of those. And also the resourcing. What are the resources we have allocated for this thing? Obviously, if you've got more labourers or more supervisors involved, or you've got 2 curbing machines, it's going to take less time. Now, materials, the materials are the materials. So, you know, this particular work package requires 10 cubic meters of concrete, and you're not going to achieve anything by having 12 cubic meters of concrete, because 2 cubic meters is going to get thrown away. So you apply expert judgment, experience, you do a bit of calculation, and risk evaluation, and what you come up with is the work package duration. How long is it going to take us to do this quantity of curb and channel? In this case we've come up with 8 days. Notice the weekends don't count because we don't work on the weekends. So work package estimation, the way you do it is experience. It's a experienced person's guess or estimate, and the best people to do this are the supervisors, the people that do it actually on the ground, and they can say, yes, it's going to take us this much, or that ground looks a bit puggy, or the concrete people are delivering late, or that new guy you've given me is not very good. So they'll be able to give you a pretty good estimate on how it is. So also previous work packages, so you could have done it before and said, oh well, it took that crew about 10 days to do 100 meter to do 1,000 meters. They're going to do about 100 meters a day. So your experience as well. Parametric estimating, you could use industry figures, or you could calculate parameters from previous projects, and that is the duration is equal to the quantity times the performance rate. So the performance rate is how quickly you can do it. So it might be 100 meters of curb per day, or it might be 30 meters of pipe laid per day. So that's what the performance rate's all about. And you might use both of these together. And activity resources. So another one is if you've got something new that you haven't done before, the best way to do it is to break it into activities. So take that work package, break it down into little activities, and then calculate the activity for the duration for each activity, add up the activities, and you get the total thing. So that's from first principles. Once again, the quantity times the performance rate equals divided by the number of critical resources. That gives you your duration. So once again, you use your experience. You say you break it down into activities to lessen the effect of things being different. But you'd only really use that for an activity that you a work package that you haven't really done before. Parametric estimating is a parameter is a basic unit of work. So square meter of building, or linear meter of pipeline, or whatever it is. So the number of units of work can be carried out in a unit of time. So previous projects, measurement, or industry figures. So here's something straight out of Rawlinson's for bulldozers. So a D6 bulldozer pushing material over a distance of say 80 meters can do about 120 cubic meters per hour. So this provides you with a bit of an idea of how long it's going to take. Now Rawlinson's is notoriously over conservative, so it's your last resort. Really your first prize is someone that's done it before, experience, or actually just going out and watching them, watching how long it takes them to actually bulldoze that and estimate how much material they're actually pushing on the day. Now there's a couple of other estimating techniques that we're not really looking at on this course, but you do need to know what they are, but we're not really going to be doing them. So if you did future courses, you know what we're talking about here. So another one is called PERT, Program Evaluation and Review Technique, and this is a way of lessening the unknowns. So you calculate the duration based on a weighted equation considering optimistic, most likely, and pessimistic estimates. So you come up with 3 estimates. You say, if everything goes really well, how long is it going to take us? It's going to take us, say, 4 days. If everything turns to clay, how long is it going to take us? It could take us 8 days. And what's the most likely time it's going to take us? It's going to take us 6 days. So you take the optimistic, which is what, 4 days, 4 times the most likely, so you're putting a weighting on the most likely one, so 4 times 6, whatever that is, and then the pessimistic. So you add them all up, you divide them by 6, and you arrive at a number there. So if there's a reason why things could go really, really badly wrong, you're still putting a weighting in, so you're pulling it towards being a few more days than you would have if you weren't too worried about it. So that's what the PERT formula is all about. It's used on bigger projects more often, and if there's more time-related risks, or if time is really, really, really important. So you might use PERT then to arrive at the estimates. Not used typically in smaller engineering projects that we're sort of involved with. And another method is the Delphi technique. and that's iterative forecasting, where multiple experts reach consensus on an estimated duration. So what you do is you say, okay guys, how long is it going to take us to do the curve and channel? You've got 5 experts in the room, and this guy will say, oh, it's going to take 11. So initially they don't talk about it, they just sort of come up with their own estimates. This guy says 11 days, this guy says 15, he says 8, he says 16, he says 12. Now you all compare the estimates and you discuss it. This guy might say, well, I thought it was 8 days because, you know, my experience is that it's really good, you know, on a really good day we can do it really quickly. This guy will say, well, we're entering winter, it's going to get quite, you know, there's a higher risk um, of us losing time to rain. And so each one of these guys, they'll have a bit of a discussion, and then they'll go through and they'll estimate it again. So this guy sort of goes up a bit, saying, yeah, you're right, I haven't allowed for rain. This guy might come down and say, yeah, I was probably being a bit pessimistic. Once again, they discuss it, and then they sort of come up with sort of about the same one. So the Delphi technique is a whole lot of experts, and gradually they estimate and they discuss, estimate and discuss, and come to a consensus on what the most likely time for that, or most likely duration for that work package is. Now, as I mentioned before, the PERT technique and the Delphi technique, we're not doing them on this course, but you do need to know what they are.